The intent of this video is to give you some hints on how to solve some of these algebraic problems. In this first example, we have two fractions that are equal to each other. Now we could multiply both sides by some numbers to get rid of the denominators and simplify. Or another thing to think about here is this is when you would cross multiply. Multiply the 7 times the quantity x plus 2 and 5 times the quantity 2x minus 3. Number 2, in this problem there are 4 different terms. 3 of them are fractions, and if we got a common denominator between those 3, it would be 12. Multiply all these terms by 12, that would get rid of all denominators, and then you could work with just a linear equation without any more fractions. Number 3, we want to solve this one by factoring. You could do guess and check, or you could try the split middle term method. 6 times 4 is 24. And then I'm looking for two numbers that multiply to 24 and add up to 11. That would be 3 and 8, or 8 and 3 would be the same thing. We use these two terms to split up that middle term. In other words, this 11x is going to become 3x and 8x. Let's add up to 11x. I'll keep the 6x squared the way it was. I'll keep that plus 4 at the end the way that it was. And then what we can do is we can factor this by grouping. I'll group these first two terms together and group those last two terms together. And now look for GCFs. The GCF for these first two is 3x. And if I take a 3x out of both of them, it becomes 2x plus 1. And then a GCF for these two terms would be 4. Inside of parentheses, we have 2x plus 1. And if it's possible, and if we did it correctly, those two terms should be the same, which means in factored form, this would be 3x plus 4. Those are the coefficients we had out front, times the like term of 2x plus 1. Here it is factored. Set each of these individual parts equal to 0 and solve it, and you should get those solutions. Number 4, use the quadratic formula. And if you don't know that, you can look it up. Once you have that evaluated, then you need to break down the radical a little bit. And once you have the radical simplified, then all 3 terms, the 2 terms that are in the numerator as well as the 1 term in the denominator, can all be simplified with each other, which should lead to that solution. Number 5, you could use either elimination or substitution. I would probably use elimination, multiply the first equation by 5, multiply the second equation by -6, and then you can solve for y, plug it back in to get x. Number 6, you can't just add them together like this. This would not turn out to be the square root of 100. Instead, break down each one of these terms, square root of 4 and square root of 5, multiply the square root of 20. The square root of 4 is 2, plain old regular 2, square root of 5, plus, and then do the same type of thing for the square root of 80, and then this, plus how square root of 80 breaks down, should come out to an answer of 6 root 5. Number 7, in evaluating this, we're going to plug in this 5 root 2 for the r, and we're going to plug 6 in for h. The difficult thing in this one is squaring 5 root 2, and you're squaring the entire number, the entire term. When you square the 5, that becomes 25, and when you square the square root of 2, it becomes 2, which means that 5 root 2 squared is equal to 50 for that part, and then evaluate the rest. Number 8, this is actually what's called the distance formula. We're trying to find the distance between those 2 points, and the subscripts means we're talking about point 1, x1, y1, and point 2, x2, y2. Plug those values in, subtract and square, add them together, simplify down the radical in the way we did the last one, and you should get that length of 2 root 29. For numbers 9 and 10, I have these QR codes which you can scan and get a more in-depth explanation on how to do these problems, since these are likely ones you haven't seen before in Algebra 1. However, they are good skills to have for certain geometry problems that we'll be looking at.